In this lesson, we will learn the definitions of the terms used in acid-base calculations. And let's start with pH. So pH is a measurement of the free hydrogen ions in a water solution. Measurement of H plus ions in water solution. Specifically, the way we measure the H plus ions is we find the negative log. So pH equals the negative log of the concentration of hydronium ions, so H3O plus, concentration expressed in moles per liter, or molarity. So let's look at an example. So say we are given a molar concentration of hydronium, so H3O plus concentration equals 1.2 times 10 to the negative fourth molar. So let's punch this into our calculators, and we will find the negative log of 1.2 times 10 to the negative 4. And that is a pH of 3.92. And notice that because it's a logarithmic measurement, it is a dimensionless value. So the pH is 3.92. Now let's look at pOH. pOH is a measurement of hydroxide ions. OH minus ions in water solution. So the pOH equals, similarly to the pH, the negative log of the molar concentration, but in this case of OH minus. So let's look at an example. Say we're given a concentration of OH minus of 2.7 times 10 to the minus fifth molar. So what is the pOH? So the pOH equals the negative log of 2.7 times 10 to the minus fifth power. Punch that into our calculators. And the result is 2.8 pOH. There's a lot of confusion about the relationship between the pH scale and the pOH scale. So let's try to clarify the relationship. So we'll start by drawing the scale. So the scale begins with 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we'll number it. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the pH side of the scale. Now the pOH side of the scale will be the inverse. So pOH, and it will begin at 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So notice that from 7, less than 7, to 0 on the pH scale, we have acid. From greater than 7 on the pH scale, we have base. And for the pOH, it's the inverse. And remember, at 7, we are neutral. So we have a neutral value. Notice that there's a directly inverse proportional relationship to pH and pOH. As pH increases, pOH decreases by the same proportion. When pH decreases, the pOH increases by the same proportion. So it's a direct relationship and it's an inverse relationship. So pH equals the negative log of the hydronium concentration, H3O plus, in moles per liter. And if we want to find the hydronium concentration, we would say 10 to the negative pH power equals the hydronium concentration, H3O plus. And for pOH equals the negative log of hydroxide ions in moles per liter. And if we want to find the concentration of hydroxide, we would say 10 to the negative pOH power equals the concentration of hydroxide. And if we take these two concentrations, so H3O plus times OH minus, it will equal to the Kw value, which is the equilibrium constant of water, which is equal to 1.0 times 10 to the negative 14. Before we start talking about dissociation constants, I'd like to clarify one other concept. And it's the concept of logarithm. Say we have a base A and we have an exponent b, and we have a result c. The logarithmic version of this would be, so we would have log base a, and we would have the result, and then we would have what would be the exponent. So if you notice that the exponent and the result are simply reversed. So we're saying, okay, we have a base of, an example would be, we have a base of 10, and our result will be c, whatever c is. What exponent, b, would we use to get the result c? So it's a very simple concept, but sometimes people get confused about exactly what logarithms mean. Let's talk about Ka. Ka is an important measure. It's called the acid dissociation constant. It's the extent to which an acid dissociates in solution, therefore its strength. So pH and pOH measure how acid, base, or neutral a solution is. Ka, on the other hand, is a measurement of the strength of the acid. So let's do an example. Say we have a Ka equals 3.60 times 10 to the negative 3. How do we find the pKa? So the pKa equals the negative log of the acid dissociation constant, or Ka, equals the negative log of 3.60 times 10 to the negative 3. Put that in your calculator. Equals, so the pKa equals 2.44 in this example. So the smaller the pKa, the stronger the acid. So this is a moderately strong acid. And if the numbers were very high, that would be a weak acid. So let's talk about Kb. Kb is a measurement of the strength of the base. So let's say we have a Kb of 5.40 times 10 to the negative 6. We would find the pKb by calculating the negative log of the Kb, or 5.40 times 10 to the negative 6th. Put that in your calculator. And the pKb equals 5.27. So a final note, pKa plus pKb should always equal 14. And Ka times Kb equals Kw, and Kw equals, it's the equilibrium constant of water, so it would be 1.0 times 10 to the negative 14. I hope you enjoyed this video about acid-base measurement terms, and I hope to see you in future videos. Thank you.